Good day. I'm Melvin Pasqua, and I am presenting to you the numerical methods for ordinary and partial differential equation using the Dev C++. Under the topic, fixed point iteration method, Gauss-Seidel method, Lagrange interpolation method. With the fixed point iteration method. The idea of the fixed point iteration method is to first reformulate the equation to an equivalent fixed point problem, such as f of x is equal to 0, and it will become x is equal to g of x, and x is the input and the g of x is the output. In numerical analysis, fixed point iteration is a method of computing fixed points of a certain function. More specifically, given a function of f defined on the real numbers with real values and given a point x of o in the domain of f. The fixed point iteration is x of n plus 1 is equal to f of x of n, where n is equal to 0, 1, 2, and so on, which give rise to the sequence xo, x1, x2, which is hoped to converge to a point x. If f is continuous, then one can prove that the obtained x is a fixed point of f. The step-by-step process on how to use the program. First, enter the initial value xn. Second, specify the terminating condition EA. And third, set the maximum number of iteration. Okay, we have here an example problem. The output voltage on a given function generator with varying phase angle is given below. Determine the value or the magnitude value of x that will output a value of negative 10 volts using the fixed point iteration method, and terminate if EA is less than or equal to 0.00001. After writing the source code, press the compile button F9 and F10 to run the program. You can also use the compile and run button, which is F11, then input the required values or parameters to solve for the required values on the problem. So for example, enter the initial guess, let's say 5, enter, and asking for the tolerable error, which is 0.00001, enter, and asking again for the maximum iteration. We can choose any, so let's say 10, enter, and as we can see, after the 10th iteration, we can have here, or we can see here, the result is 2.699668 and 0.00004, as and we if we compare this one to the tolerable error that we input, this is smaller than this, and we can say that our problem is, or that our solution in the dev C++ is very good to use. Okay, so this is the fixed point iteration method. Our next method is the Gauss-Seidel method, also known as the Liebman method or the method of a successive displacement. It is an iterative method used to solve a system of linear equations. This technique introduces a newly computed variable to the next computed variable rather than the next iteration in order to forcefully accelerate convergence, thereby improving set of computed variables for the next iteration. A step-by-step process on how to use the program is: first, enter the number of equations. Second, input the elements of the augmented matrix following the format of a typical matrix. And third, set initial value of the variables x0, x1, and x2. And lastly, specify the terminating conditions. Example problem on the Gauss-Seidel method. Evaluate the derived system of linear equation from a given nodal analysis circuit using the Gauss-Seidel method. Use a terminating condition of EA less than or equal to 0.0001 for each variable. So this is the source code for the Gauss-Seidel method. So again, we have different inputs that will be asked by the program. The first one is the number of equations. So it's either equation, three equation, or four equation. It depends on the problem. So on our example before, we can say that we have three equation and three unknown. So after that, we need to enter the elements of the augmented matrix. We also need to initial the initial values of the variables. Okay, so we after it we can compile. Okay, F9, run, compile and run. So let's try to run it using the previous example. Okay, so enter the number of equation. Our number of equation in the example is 3. So 3, enter, and enter the elements of the augmented matrix row wise. Uh, so as we can see sa ating example, at our example a while ago, we have three unknown, which is the I1, I2, and I3. So let's input the augmented matrix or the element of the augmented matrix row rise. So we have the I1, I2, I3. So at the first equation, we have I1, which is 5. Uh, enter na, yeah, 5. Then tab, and then we have 3 tab. Sa I3, sa equation 1, we have negative 7, and then tab, and the constant, which is 0. Enter, and we'll go to the second equation. We have I1, 3, tab, and then negative 5, tab, 2, tab, and the constant is negative 8. Enter. And lastly, the third equation, which is I1, is 7, I2 is 5, I3 is negative 3, and lastly, we have 16. And enter. That is the augmented metric row wise. And then enter the initial values of the variable. The initial values of the variable is 0, 0, and 0. That is our initial variables. And enter, asking for the accuracy up to which you want the solution. And we have 0.00001 as our EA, and then enter. As we can see, upon entering it, we can see here, we can see here that our I1 I2, I1 is, yeah, is equal to 1, the I2 is equal to 3, and the I3 is equal to 2. So that how to do the Gauss Seidel method using the dev C++. In numerical analysis, Lagrange polynomials are used for polynomial interpolation. For a given set of points, x of j and y of j, with no two x of j's values equals, the Lagrange polynomial is the polynomial of lowest degree that assumes that at each value of x of j, the corresponding value y of j. Here is the step-by-step process on how to use the program. First, enter the number of data points. Next, enter the value of x to find f of x, and enter the value of the independent variable x whose corresponding values f of x are to be determined. And let's try to consider this sample problem. Use the Lagrange interpolation method to find f of x at x is equal to 10 using the data set presented below. Use a terminating condition of EA is less than or equal to 0.00001. So this is the source code of the Lagrange interpolation method. In this method, it is more complicated method. Okay, and the program will ask the number of points for the interpolation, then the values of x. So let's try to run this. After we compile, let's try to run this one and solve the given sample problem. Okay, so enter the number of values. Okay, so our number of values in our example is 4. Enter, and enter the value of x to find y, that is 10. Enter, and enter the given x sa x1, our x1, where the first x is we have 5. Enter. Next is 6. Enter. Next is 9. Enter. And 11. Enter. And after which, asking for the force, which is given, we have 12. Enter. 13. Enter. 14. And 16. Enter. And this is the result of our program. The value of V3 at 10, okay, is this one, 4.6667. So this is on how to use the dev C++ at the Lagrange interpolation method.